Good day once again, everybody. And once we are back together again, right? And now we're going to be looking at 8.2. So please, if you haven't subscribed, just make sure that you're part of the family. So we are answering the technical maths paper 2 grade 10 exemplar, right? So we've already done all the other questions. Please have a look at them when you find the time. Right, so we're looking today at determining the relationship between the arc length as well as the radius of a circle, right? So they say to us, determine the central angle, that is theta, that intercepts an arc with length 4 centimeters on a circle with radius 60 millimeters, right? They say give your answer in degrees. Now, ladies and gents, firstly, let's establish what does this mean? So if we have a circle and there's the center of that circle, so anytime that I'm looking at the arc, now suppose that I'm going to just take a portion of that circle. So the angle theta would be the central angle, okay? That would cause, now please I want you to note this. So what would actually this cause? I want us to look at it with a different color. So now this portion here in blue, this would be the arc of the angle, okay? Or the arc of the circle. It's a portion of the circle, of the circumference of a circle. So now, if I want to find out what my central angle is, this is related to the entire angle, or rather the entire circle. So we say that the central angle, okay, would be equal to, now please I want you to stay with me here. We say this is going to be 2 pi r, okay, that's the circumference of a circle, divided by 360, right? And please I want you to note this, multiplied, oh, in fact, I made a mistake here. I wanted to say the arc length, not the central angle. So the arc length would be 2 pi r over 360 multiplied by the central angle. Okay? Right. There are all sorts of fancy names for that, and for now, let's just keep it as tidy and simple as that. Now, they told us that our arc length is 4 centimeters, right? So we need to convert that into meters. We make sure that they all have the same units. So what I'm going to do is convert that into meters. And remember, centi is a hundredth. So think about when you say percent, you are dividing by 100. So that's 4 divided by 100. That would give us 0.04. So the arc length is 0.04. And this would be 2 pi. Now we are given the radius of the circle, and they said it's 60 millimeters. Now milli is 1,000th, meaning we are dividing by 1,000. So I'm going to say, well, that's 60 divided by 1,000, and this would give me 0.06. So this would be 2 pi multiplied by 0.06, and this is divided by 360. And now we are looking in this case for the central angle. Okay? In fact, let me just say multiplied by theta, because we've designated that as theta. So what are we going to do, ladies and gents? We're just simply going to multiply by the inverse of this entire thing, right? Okay, so what I am going to do to get theta, so multiplied by 360, divide by 2 pi over that entire thing. So I'm going to say this is 0.04 multiplied by 360, divide by 2 pi times 0.06. Okay, and let's see what that gives us. So I'm going to say 0.04 times 360. In fact, let's do this. 0.04 times 360. 360 divided by 2 pi times 0.06. Okay, I get an angle of 38.197. Okay, so let's say this is 38.2, right? So which means my central angle would be 38.2 degrees. Please keep this in mind, ladies and gents. It is very, very crucial that we first of all know our conversion from millimeters, centimeters, as well as just to know how to relate the arc of a circle, right, to the central angle. And that is how the cookie crumbles, ladies and gents. I will see you guys on the next video when we do the very last question. From me for now, it's ciao for now.